beautiful robots. Those were shipped off to the RDM harbor in Rotterdam. We needed to create a bit of a niche of autonomy to play with these 2.5-ton monsters. So we managed to get a hold of these robots for basically scrap prices. And one of the first projects that we explored was this vault that, for which we invited Matthias Riebmann, who is working at the Block Research Group at the ETH, who's the author of Rhino Vault, a really fantastic software that allows you to design structures that are compression only. I'll address that more in depth later. And here we really sort of took that approach of hot wire cutting. We brought it to the industrial robots that allowed for much more freedom of movement, allowing us to create elements that are more intrinsic. And at the RDM, we really explored that freedom. At some point, Chris took over in the assembly. It was one of the most pleasurable moments in my work life. I escaped for a couple of days when the project neared its completion, and I was very nervous for the final assembly because all of the troubles and errors aggregate, and assembly is a nightmare. And then I came back and Chris had assembled it, and it was just, thank you, Chris. It was such a cool moment, and you pulled it off like it was nothing, and I was so stressed out. But increasingly, I start to think of architecture in really banal terms. Is in the sense that you have the market value of the built artifact, right? The building or the pavilion or whatever it is. If you subtract the cost of the materials and labor from it, the market value of your building, of your pavilion, subtract the cost and labor from it, and what is left is architecture, right? And I think maybe it's instrumental to think of architecture in these kind of dumb, banal economic terms. Maybe there's something clever about it. So I mentioned before that we utilized this Rhino Vault in this project. Here you see the faces of the elements are normal to the thrust vectors of the building, of the pavilion. So foam, EPS foam, can deal with a lot of compression strength. So the design was optimized such that only compression forces acted upon the structure. Now the problem with the structure was a little bit that while its materialization was kind of smart and highly cost effective, in terms of materiality, maybe there was something